Hope my intelligent idea will visible.
Yes, sir.
Okay. So we have to discuss first the logic, how we can remove uh, first node from the doubly linked list, and also we have to discuss how we can remove last node or tail node from the doubly linked list. So let us first discuss about the concept, right? So
Yes.
as you know, in the doubly linked list, each node maintain two link, one the next link, another is the your previous link. So let us assume that this is the linked list exist. They have a some value, anything like 2, 5, 7, 1. Okay, and this node is next pointing to this node, and this is previous node pointing to this node, right? Similarly, this next pointing to this node, and this previous pointing to the this node. Next node pointing to the this, and previous pointing to the this node. So this would be your head, and this would be your tail. So you know what would be the next of this? Next would be null, and what would be the previous of this? Would be null. So in doubly linked list, your head previous would be null. In the case of tail, always your next would be null. Is it clear? Any doubt?
No, sir.
No.
No, sir.
So let us assume if you want to remove this last node, so what you need to change? You need to change this should be last. That means this should be pointing to null, and now this should be tail. So what the logic you have to do? The logic you have to do, whatever the last node, just move to the previous one. Now move to the previous one. Now this is the new node, would be last. So this would be your last node. Okay. But what the next? Next would be null. So you have to do three things. First, from the tail node, you have to move the previous node. And whatever the previous node have a next part, just point it to the null. And then say ki this is the my node is the now new tail. Is it okay?
Yes.
Similarly, for head, if you want to remove this head, what I have to do? Whatever the head you have, just move to the next. Here you come. What the previous would be? Previous would be null. The set previous would be null. And now say, now this is my new head. The same logic we are going to write. Logic is clear? Okay.
Yes, sir.
So let's write the code. Okay. First, you create one class, doubly, right? And this have a similarly one node. Node should be your head. Node should be your tell. Okay, and just create one class that should be node, and this have a like a variable integer your data and your previous and like a node nest, right? And just make one constructor. Now first you have to let some void add method that will add some data, integer data. Add logic you already do, just you create a node, new node equal to node, and pass uh, data, and you have to pass previous, you have to pass nest. Okay, so whenever you creating the any node, as you discuss what would be the previous, what would be the next. So I know whenever I'm going to create a new node, next would be always null, but previous always you do the tell, right? Because we are going to add always node at the last. And just here check if might be case our head is a blank somehow, null, not created, then you have to just assign this is the, then you can say else. Always say whatever the uh, new node, that would be the tell after the read, because we are creating the last node. And here you can say if head is null, then head would be the new node. Else, if this is not new node, that means whatever the tell we have a tell dot next equal to the new node. Okay, this is the add method. Somehow we have to able to, let's uh, uh, check like the show method void. So any doubt, please ask. Okay, in any method, just start with the node temp equal to head and while loop. If temp not equal to null, then just print the value whatever the temp dot data part and just make one space. And after that, you can say temp equal to temp dot next. And after this, just make a one space. Similarly, this is the let's key. So from head, because this is the doubly linked list, so you can move from both direction, from head to tail or tail to head. This would be from tail. Just here you have to change. We start from tail and just move to the previous node. So let us just check it's my first add work or not. Just create a doubly linked list equal to new doubly linked list and just add some method like add, and here you write like 2 like 5 like 7 like 1 9. Okay, and just check its work. Doubly linked list dot, this should be basically private. Okay, so don't show anyone. Okay, so don't anyone access. This should be your static private, so that only one class. So that here someone try to access dot, they can only get the public method, right? So ERA, so from head, similarly, so from, just check my linked list is created or not. Okay, somehow you have to write not new line, similarly, so that we can visualize in two line only. So now our linked list is created. Here from head to tail we reach, and here from tail to head we reach. Now let us going to remove first and last. So write one method. Let's add some more data like 70, like 79. So in this case, this is my linked list. Here I want to remove the first head. So now our linked list should start from 5 to this. And whenever from reverse you print, we only print from this to this, right? Because you want to remove our head. So let us write like void uh, remove head. So let us again repeat our logic. What we are going to now, this is your head node, and head pointing to the nest, and this pointing to the nest, and this have a previous, this have a previous, and this is your head. Okay. So first, whatever the head you have jumped to the is nest part. And now this would be your head, right? And but the previous would be also null. Previous would be null. Here we have to set this logic, and now it's done. So let us say whatever the head you have, just move head equal to head dot next. Uh, whatever the head dot previous would be null. Any doubt? Let's check it. Just doubly linked dots are remove head and just print. It should be removed. You notice in the first here is a two not available, and in the from two to last your head is removed. Any doubt how to remove first? Any doubt?
No, sir.
So let's remove the last. Wide remove last or tail. As usual, what are the logic you have to write? Let's example again, repeat the logic. Now this is your linked list. Before writing code, just think what you are going to do. So now this is your tail. Now I want this should be removed. That means this should be your tail. A tail always pointing next to null. So this next should pointing to the null so that we cannot reach here. So if we traverse from head to nest to nest to nest and next null, we stop. That means this is only linked list. And you can start from tail. The tail is this previous, and you are retrieving. So here, what you do, whatever the tail you have, just go to the previous one, right? if you move to the previous one, then what you do? Whatever the nest set to null. So let's do whatever the tail you have, just move the tail dot previous. You move to the previous. I you know tail dot next would be null. Let's check it. Remove tail. Remove tail node. If we check, in this case, our what with the new tail? New tail would be here the main linked list. Tail with the 79. The 79 would be removed, right? So our linked list should be only 5 to 9. Let's check it. So your 5 to 9. Your this is the tail part. This is the tail. You have to remove your tail. But in this scenario, you have to consider the corner case. Like what happen if we have a only one node head. So head dot would be the null. So if you remove head, then what is the new linked list? In this case, head and tail both should be null. So you have to check those cases here. Here we are assuming ki always linked list created, right? In this we jump next and pointing to the null. So what happen if you say head dot next? This is only one node created. Then you say head dot previous, it will be throw exception. So whenever you are writing, let us example some scenario. What happen if I not created linked list? Then what happen? Your method, your application should not throw exception. But here, what are you doing? Removing head dot next, but head is the null. Then your application throw exception. So whenever you are writing any method, you have to check your application is not throw like an exception. You have to give some proper message. There is no any head node, right? What happened in the case of only one node is available? What happened in case of only one node is available? Still your application through exception, right? Because you are trying to say previous, there is no any previous. You are trying to set a null. So in both cases, your add method is a very error prone. So while writing code, not only consider the positive case or good scenario, you have to consider what happened when linked list is not created. What happened if I have only one node? So whatever you are going to do, you have to check first if head equal to null, head null, then what you have to do? You have to do nothing. Okay. Just write a method. Linked list is not created. Okay. That's out. Link linked list is not created. Right? At least one scenario you save. If let's say no linked list is created, if someone invoke your method, at least you give proper message. Your linked list is not created. Right? So you handle one case. What happens if only one node available and it should work your code, but still you are throwing some exception? That means you have to consider else part. Okay. What happened? What is currently happen? They have only one node. You say head equal to head nest. What is the nest? Nest is the null. and you say again head dot previous. That means this is a new head. That previous null doesn't have any kind of previous things. So what do you mean? This means they have only one node exist. So if I want to remove head, that means after that our linked list is a blank. So you have to add some scenario. Okay. So here you have to check. But check whatever the you are getting head dot next, still this become a null if head is still null. That means you have to give some message. What the message? That means ki only one node, you deleted that. After that, there is a no linked list. So in this case, head and tail should be null. Head null and tail should be also null. Right? So in this scenario, if you run, now you can handle the scenario. Now it's again problem with the remove method. At least if you are not using a remove method, it will works, I think. Okay? Okay? At least it will, you can now play a only one element, and after removing, there is no element available, right? Because you have to remove the tail part. If let's we have a two element and you remove head, that means still you have a one element, five. Five should be head, five should be head. If this is the three element, it should be good. You have to remove the first. Still linked list created, 5 and 7, right? So whenever you are going to write message, you have to consider, that's in this case, you have to maintain your head part, remove head, you have to retain the logic. Similarly, this logic is works for the if your linked list is created, there is no kind of any exception. But what happen if the linked list is not created? Someone not added node. I invoke your method first, like here. If let's linked list not created and someone invoke your method, remove tail, you will throw exception because you are doing not adding any checks. So here you are get throwing exception because here you are not maintaining the scenario. Here you also have to think what happen if linked list is not created. That means if your tail is null, then what you do? Else what you do? Right? If tail null, you can say linked list is not created. Like similarly, okay. Similarly, what happen if they have only one node is created? Only one node. This is the head and this is the tail. If you remove tail, then what is the next tail and head? Next and tail and head should be null because there is no linked list after the removal of one element. So here again say what happen if again previous would be null. If is equal to null, then what you do, else what you do, right? You have to give the message. Now linked list is a blank. No more element in the linked list. You can say anything. So if you run it, now your application will not throw any exception because you have to say two times you want to remove the linked list. This is no element. Let's assume you have added only one element in the linked list and you have to add. So you notice one is created and was head removed. After that, linked list is blank. So let us just remove not head. I just try to remove the tail part. If I have only one element, tail should be removed, and after that, yours should be blank. Your tail is removed two times. This is a two times printing, and after that, you are getting a blank. There is no any linked list. So such scenario, whenever you are writing code, you have to take in care. What happen if the such scenario happen? Else your code is working fine for all the scenario. Yes, any doubt about how we can write method to remove first or remove last or remove any?
No, sir.
Hmm?
No, sir.
Okay. So whenever uh, any other question with the respect to doubly linked list, now it's clear how you can remove head node, how you can remove the last node.
Yes.
Good.